Welcome. We're going to have some fun in this session. We're going to get involved with the debate, the great Twitter debate, hashtag no estimates versus hashtag yes estimates. I'm James Shore. I'm the co-author of a book called The Art of Agile Development, which you can find at the O'Reilly booth outside. And I'm also co-founder of the Agile Fluency Project with Diana Larson and Adam Light. So there's these two camps, no estimates or estimates. And the no estimates folks say estimates are waste, value is more important than cost, estimating leads to dysfunctional behaviors. The yes estimates folks say, hey, we've got a legitimate need to control costs, we need to make commitments, if we refuse to estimate, that's going to piss people off. So the question is, who's right? Who is right? Why don't I just get you to tell me? No estimates is right. Hands raised. All right. Yes estimates is right. Hands raised. Wow, that's pretty much 50-50, although since this is developer focused, I'm not surprised to see a bit more no estimates than estimates. Who's waiting for me to tell you which one the right answer is? Everybody. All right. Well, first off, well, they're both right, actually. Or at least these are all legitimate points. These are all true things. Nobody is lying, nobody's making stuff up. These aren't straw men, these are all real. Estimates are wasteful, and there is a legitimate need to control costs. All of these things are true. Before we get too much into this, I just want to set aside something. The word estimates is the wrong word. Estimating is a tool. What people actually want is predictions, or some people call them forecasts. And so you might see people sort of weaseling around this saying, well, we still want to do predictions, we just don't want to do estimates. But if you use the word predictions, all these things are still true. In fact, when people say estimates, what they really mean is predictions. So yes, predictions are waste. Predicting does lead to dysfunctional behaviors. Refusing to predict does alienate stakeholders. So I'm not going to get out of this by saying, oh, just use the word prediction instead of estimates, you're fine. All right. So, which of these is right? Two key questions. When should we make predictions? And even when we should make predictions, can we make predictions? Do we have the ability to make predictions? I think if we can answer these two questions, we can answer the questions of whether or not predictions are a good idea. I'm going to start out with the second question. When can we make predictions? And the answer is always. We can always predict anything, and we can do it with accuracy. In fact, I can predict. How many of you in the audience have a project that you're working on right now that you could use a prediction for? Anybody who's not raising their hand, I'm sure there is something. I will now proceed to predict all of your projects with 100% accuracy right now. Your project that you're thinking of right now will complete sometime this century or not at all. Accuracy isn't the problem here. Precision is the problem. We can predict anything, but doing it in a way that's useful, that's harder. And in fact, for software projects, if you have a project that you're working on right now that is currently predicted to be done in a year, very realistically, it will probably be done in the next 1 to 4 years. But if you were to tell your stakeholders that, if you were to tell your managers that, or whoever's paying for this, that it will be done in 1 to 4 years, you're probably not going to get a happy response. How many of you can get away with that? One person, 2. Cool. So, if you take any point prediction, it's going to have an accuracy that's going to fall into a range. The reality may end up being exactly as you predicted. The reality may end up being further away than you predicted, or the reality may end up being sooner than you predicted. This is sort of a tautology. If you take all of your predictions over time and you sort of figure them all out and you graph them out, you will get a graph that looks a lot like this. This is a graph that was created by Todd Little, and he put in a paper for IEEE software called Schedule Estimation and Uncertainty Surrounding the Cone of Uncertainty. I really like this article. And he took 100 projects at his company at the time, Landmark, and he put them on a graph like this, and this is the real data. So that circle right there, those are the number of projects, the percentage of his predictions that were exactly right. And that's the percentage of predictions that was double, or half of the reality, and that's percentage of predictions that was 1/4 of reality. Now, those numbers, knowing that, 3% of his projects were exactly as predicted, is not very useful to us. What we really want to know is what percentage of his projects came in exactly as predicted or sooner. Because if you know that, you can say, this percentage of my projects are going to come in when I predicted. Well, it turns out that for his projects, 10% of the projects finished by the prediction. And this is actually really typical data. Your projects will probably fall in this curve. Now, if you really want to know, you have to do 100 projects and map your own curve for your own company because there are differences across companies. But since you haven't done that, because nobody ever does this except for Todd Little, this data is actually pretty close to typical software projects. So 10% of his projects were finished when they were predicted to finish or sooner. 50% of the projects were finished in twice the time predicted or sooner. And 90% of the projects were finished in 4 times the amount predicted or sooner. What this means for you, since these numbers are very typical, is that your raw prediction, whether you use estimation or another technique, your raw prediction will be right about 10% of the time. If you double it, you'll be right about 50% of the time, and if you quadruple it, you'll be right about 90% of the time. So you can go to your boss and say, our raw prediction is 3 months, which means that we will be done sometime in the next 3 to 12 months. Or you can say 10%, 3 months, 50%, 6 months, 90%, 12 months. I find that describing the likelihood of a date is very confusing to stakeholders. They do not like it. So I use this language here. If I have a raw prediction of 3 months, which means that it will be done sometime in the next 3 to 12 months, I will say, you can count on us being done in 12 months. That's our commitment to you. And we're working on getting it done sooner for you as a stretch goal. Our stretch goal is to have it done in 3 to 6 months, but you can count on it being done in 12 months. And then 10% of the time, even that will be wrong, but what can you do? If you wanted to be 100% likely, you'd have to multiply it by about 8 to 10, and that's just not useful. So there's a problem here. Even with a raw prediction of 3 months, that gives you a range of 3 to 12 months. How many of you can get away with that? Same 2 people. 3 people now. Yeah, so this is the problem. We can predict anything. But useful predictions are a real challenge. If we want to have useful predictions, we either need to reduce the time frame, that is, only predict in very small pieces, predict something where the raw prediction is 1 week, and then it will be done sometime in the next 1 to 4 weeks. Or, and that will work, saying to somebody, yes, this thing that you've told us to do, we will have that done in a month, and our stretch goal is to have it done in the next week or 2. That's not so bad. It's when you start getting to 1 to 4 years that people just go crazy. So you can reduce the time frame or reduce the variance. Because again, it's the precision that's hard, and what makes that band wide, what makes it 1 to 4 times, is variance is its unpredictability in various elements. Now, I've identified, there's lots of things that can cause variance in your predictions. I've chosen 5 here. 5 are the most common. One is individual availability. If somebody is assigned to another project or goes on paternity leave or gets sick, then that's going to change how quickly you get things done. Second is team interruptions. If your team is pulled off this project to work on another project, or if they're working on 5 projects simultaneously, that's going to create a lot of variance. And again, it's the consistency. If your team is pulled off of its project 30 hours out of every 40, 75% of the week, but that is the only interruption and everything else goes exactly according to plan, that's very easy to predict. You can account for the inaccuracy that's caused by not being 100% on this project if it's really consistent. So accuracy isn't the problem here. The problem is precision, which comes from consistency. We want consistency in order to make good predictions. So, but in a lot of places, the team is not 100% assigned, so they get pulled off to different projects, and you can't predict that in advance, and that creates this large variance. Technical uncertainty is another big source of variance. It's very hard to predict how long it's going to take to solve a particular bug or to research a particular technical problem, and so forth. Technical debt is a very common problem of this sort of variance. And of course, scope variability. People changing what they want or adding to what they want. You probably call it scope creep. Finally, dependency reliability. If you depend on other parties in order to get your work done, and either they have to ship some software to you, or well, that's the most common one I can think of. Or let's say you need to get information about requirements for somebody who's not available. That's a dependency. And that person or team's availability is going to determine when you get done. Okay. So if you want useful predictions, you need to decrease variance. Well, I've got good news for you. If you're using Agile, at least the first 2 aren't a problem. Agile teams are assigned, that individuals are assigned 100% of the time to the team. Agile teams schedule all their work with stories. They don't have random interruptions. I mean, it's not perfect, but we don't want to eliminate all variance. We just want to get it down to the point where it's useful. So this is true for Agile teams, right? 6 people in the room. It's like 1%. I want to take a moment. This is what some Agile teams can do, but not all Agile teams have achieved this. And so I want to describe something that Diana Larson and I created called the Agile Fluency Model. This describes how teams tend to grow in their understanding of Agile over time. Teams, I'm not going to go into it in a lot of detail right now. If you want more information, it's at agilefluency.com. But in general, there's a bunch of skills, a bunch of proficiencies associated with Agile development. And in general, teams tend to develop those skills in a fairly predictable way. So we've got it described in terms of 4 bus zones, 4 zones, which we've described as stars. And the first zone is what we call focus on value. This is where you've got a team that can change direction according to business needs. Some of the skills that you see from teams in the 1-star zone is that they are assigned 100% to the team and that the work is scheduled with stories rather than coming in through, side channels. Teams that are fluent at those skills actually are able to do that. Now, the thing about the fluency model is that all the zones are worth going to, and it's not a maturity model, so we're not saying go to zone 4, otherwise you're crap. Actually, for most companies, most teams, zone 4 is inappropriate. The team has to drive the bus to the bus zone. So if you are on an Agile team, it's your responsibility to figure out how to get to the 1-star zone, how to focus on value, how to work in terms of user stories, and so forth. But here's the catch. Team drives the bus. The organization has to buy the bus ticket. If your organization isn't willing to assign your team members 100% of the time to the team, if they're not willing to schedule work by using stories, then you're not going to make it to zone 1, no matter how much skill your team members have. But teams that have reached that 1-star zone really can count on good enough individual availability, good enough team interruption consistency that these sources of variance are not a problem. So now we're good, right? Now we can make useful predictions, right? Yes? No. Because teams that are now at this 1-star zone that are changing direction and according to the business needs are now incurring a lot of technical debt. When you change direction all the time on usually a 1-week or 2-week cadence, and you've given up on that terrible monster of big design up front and waterfall, you're no longer doing design, you're creating kind of a mess in your code. So these 1-star teams actually have more technical uncertainty than non-agile teams. And of course, all the work that used to be scheduled through sort of interrupting the team now comes in through stories. So we've still got even more scope variability. Bottom line is that most agile teams can't make useful predictions. They're just not capable of it. I mean, they can make predictions, sure, but the time horizons involved are so large as to be useless. So unless you use very short time horizons, you can't make a useful prediction in most agile teams. So what do we do? Do we give up on this agile thing? I've been in the agile community since 1999. I'm a little bit invested in this. This is uncomfortable. Okay, there is a silver lining. Turns out that the 1-star zone is only the first stop on the journey. And some teams travel to another zone. The 2-star teams have the technical expertise to change direction without incurring a lot of technical debt. They have low defect rates, and they have high productivity, and they have very good consistency in their technical work when they're not solving completely innovative problems like self-driving cars. And if you're in that space, don't bother making predictions until you've solved the hard problems. And they do this with the XP engineering practices, stuff like test-driven development, refactoring, evolutionary design. Several years ago, I shepherded an experience report for somebody named Nancy Van Schoendewert, who is focused in the embedded system space. And she had this great experience report talking about how her team of developers tried XP, Extreme Programming, for the first time, and had some interesting results come out of that. I like her paper because it has lots of detailed metrics, and it reflects what I typically see from these 2-star teams. So her team was building software for a farm combine. It was an embedded system written in C. It was multiprocessed. And she had a team of people, well, I'll get into that in a moment. Capers-Jones, who studies these sorts of things, says that for a piece of software of her team's size in her problem domain using her language and industry and so forth, average team will produce 4.5 defects per function point, which comes out to 1,035 defects. Average team will find 80% of those and ship 207 defects to their customer. A best-in-class team will produce 2 defects per function point, find 95% of them, and ship 23 to their customers. Nancy's team was staffed with people who had not done this kind of work before. Some of them had never worked in C before, some of them had never done embedded systems before, some of them had never worked on multiprocessing systems before. This is not a recipe for success. And in fact, they found 59% of their defects. This is what Capers-Jones would call best in class, average, malpractice. So how many defects do you think they shipped to their customer? I'm sorry? 10, good guess. They shipped 21. In fact, they had so few defects, they had 51 defects over the entire life of the project, which was 3 years of total work by the team at the time this paper had been written, but a year and a half, the initial year and a half of that was full-time development. They shipped so few defects that they did root cause analysis on every single one. They never had more than 2 defects in their backlog at any given time, and they averaged a defect rate of 1.5 defects per month. This is what I see from teams who have achieved true fluency at that 2-star level. What that means is that the technical uncertainty is no longer an issue for these 2-star teams. And what that means is that now our variance is low enough that is we have something that's good enough to use. Now we still have scope variability and we still have to manage dependencies. But now a 3-month raw prediction is useful. Now you don't have to have a 2-star. So a 2-star team can ship to the market whenever the market is ready. And if you're in a web project, that means you're shipping multiple times per day. You're doing continuous deployment. You actually don't have to be that good. You don't have to be that fluent in order to see these kinds of results. If you're using iterations, you just need to have a rock solid velocity. You're doing the same amount of work, or you have the same velocity every single iteration, and you're shipping a very small number of bugs, 1 or 2 a month. If you do that, then you get to use a different set of multipliers. So now, before you would say, you can with a raw prediction of 3 months, you would say you can rely on us being done in 12 months and we have a 3 to 6 months as a stretch goal. That doesn't really fly. But if you've got this, if you meet these criteria, now you can say you can rely on us being done in 5.5 months and we're working on 3 to 4 months as a stretch goal. That's much more palatable. That actually starts to come in the realm of acceptability. Now, I have to caveat this. The risky numbers, the 1, 2, 4 numbers, that's a pretty common experience. I feel very confident saying that most of you fall into that category. The 1, 1.4, and 1.8 numbers, we don't have the same sort of studies of XP teams that we do of normal software projects. We don't have studies of these 2-star teams. So I came up with those numbers by using a Monte Carlo simulator that was produced by Tom DeMarco called Riskology, and using my own intuition about what the risk factors are. My actual experience has been better than this. And the nature of the curve is that the outliers happen fairly infrequently, but when they do happen, they're big. So I don't know exactly what the numbers are, but I feel pretty confident saying that you'll get that you'll fall into this category or better. And if you really want to know what the multipliers are for your team, you've got to do 100 projects, graph them, and see what it is. So get back to me in 3 decades and let me know what you think. So bottom line, most Agile teams can't make useful predictions except in very short time horizons, but 2-star Agile teams can. Before we move on, I want to talk briefly about how we get that raw prediction. I was talking about, a 3-month raw prediction or a 1-year raw prediction. There's lots of techniques for doing this. It's not even that hard. Some of the no estimates folks, in an attempt to sidestep the whole issue, talk about making predictions without doing estimates. Here's some of the techniques. If you are using estimates and you're using iterations and stories, you can predict how long something will take by adding up all your estimates, dividing by your iteration velocity. That's the number of iterations. So if you've got 100 points worth of work to do and you get a velocity of 10, it will take you 10 iterations to do it. If your iterations are 1 week long, it will take you 10 weeks. That's your raw prediction. You can also make predictions without estimating at all. Joshua Karievsky famously advocates for this, but he cheats. he has got a lot of experience, and he just creates his stories and splits them up until they're all the same size, which is sort of like estimating without estimating. And then he counts up the stories, divides by how many he gets done in a week or an iteration, and then there you go. So if you've got 40 stories and you get 4 done every week, then it will take you 10 weeks. Another approach, which I learned from Arlo Belshi, is kind of neat. For those of you who are not doing iterations, you can use something called Disney line planning. If you go to the amusement park, if you go to Disneyland before they electronified everything, you would stand in line, and sometimes somebody would hand you a card and say, please hand this to the person, the operator at the front of the line. And on that card would be written the current time. Then when you hand it to the person at the front of the line, they look at their watch and they say, this person from a known point took 30 minutes to get to the front of the line. And so they can say, that's when they put out the little stand that says, your expected wait from this point is 30 minutes. That's Disney line planning. You can do that with your stories or features if they're all roughly the same size. You can say, when something comes in, you can measure, you can set the time, and then when it's done, you can get the next time and say that took 3 weeks. So a typical wait for a story in the second position is 3 weeks. And then write down the time when it gets to the first position, and so forth. We don't really have time in this talk to go into a lot of detail, but it's not that hard to make predictions. Again, the challenge is the variance, is the precision, not the actual prediction itself. So, bottom line, 1-star teams can't predict. 2-star, 3-star, and 4-star teams that are further along their journey, can predict. Of course, the organization does need to buy that bus ticket. To get to 2-star, you need to give the team time to learn these skills, and you need to accept lower productivity while they put them into practice and pay down technical debt. Any questions about the material I've covered so far? I'm not planning on stopping right at the end, so if you have questions, go ahead and ask them as we go. All right. How many of you buy this? You believe it? That was a little reluctant, but most of you raised your hand, so thank you. Okay. 2 key questions. When can we make predictions? When should we make predictions? So now we know when we can make predictions. We can make useful predictions when we've got a 2-star Agile team or a team that's further along in their journey. But should we? Well, obviously, we shouldn't make predictions when we can't do it usefully. If you've got a 1-star team and you want to predict, and you've got a raw prediction that's 6 months out, you probably shouldn't make that prediction because the 6-month prediction is going to be wrong and the 2-year prediction is going to anger people. So, that may not be useful. But when we can make predictions, should we? Predictions have a cost. These techniques are not difficult to understand, but they still take time to do. If you're estimating stories, how many of you have been through the pain of a story estimation session? How many of you enjoyed it? I got 1 person, no, 4 people. Okay, you guys should get together and talk. You enjoy a certain amount of pain. There are actually techniques for estimating quickly, and I don't have time to go into them here, but there's some really neat estimate mapping techniques that allow you to go through this quickly. But the main reason estimating takes time and is painful is not because you can't make a wild guess. It's actually very easy to have consistent but inaccurate estimates, as long as you understand what needs to be done. So the pain of doing the estimates is actually the conversations about what do you really mean. And that's a valuable conversation to have. You need to do it anyway, which is one of the reasons I think that estimating can be really useful. However, it costs. And if you want to get a prediction, a raw prediction that's 6 months out in the future, and your typical iteration got 6 stories in it, and your iterations are 1 week long, then that means you need to go into that amount of detail for 6 times 4.25, 6 times 26. How much is that anyway? I should have done this math in advance. A lot of stories. It's a lot. Anybody know the number? 6 times 26? Thank you. I don't do public math, by the way, so thank you. 156. Sitting in an estimation session to figure out the details of what you're really going to do for 156 stories, just so you can make a prediction that is going to give you 6 to, again, no public math, 10 months in the future, that's a lot of work. There's a cost associated with it. You can do it, but it's expensive. And don't think you can get away with just not doing estimates, because the effort that you need in order to do small, consistent stories is exactly the same. You have to understand the work well enough to say that these stories are about the same size and we've broken them down appropriately. Similarly, for a continuous flow, you can not go into so much detail, but then your variance starts to increase. So there's a cost associated with this. And the ideal of Agile is just-in-time work. The idea of Agile is adaptive planning. Just-in-time work is the idea that we've got a list of tasks that we're working on now, a list of stories that is in our backlog, and then from there we've got features, I've got them described as minimum marketable features, that are meant to achieve a purpose. And you can have this backlog be fairly small. The list of tasks may be just for the next week. The list of stories may be just for the next 2 weeks. And so once you finish an iteration, you pull up the first half of the backlog, and then that leaves a hole for 2 weeks in the future, which you then can pull out of your feature list. And then once you finish a feature, you figure out what your next feature after that is. So you're constantly pulling things forward, and the amount of work that you've really figured out in detail to the point where you can estimate it is fairly small. This is the ideal of Agile, just-in-time work. And the reason for this is that it makes it easier to change direction. We're not incurring all the costs. And we have less attachment to our plans. If a new idea, a better idea comes along, we don't say, oh my God, we've done 156 stories, and that would mean throwing away all that work, and I just don't want to do that. We don't actually say that out loud. We just say, nah, that's not a good idea. Making predictions requires more planning than we really want to do in an Agile environment. The idea is that we've got this fuzzy unknown future out there, and as we do the work, we learn things about the possibilities, and we explore them, and we change direction. We're Agile so that we can get closest to where the value really is for our project. That's what we want out of Agile. But some people find this vast unknown future really scary. Some people want a bright shining line saying, this is where we're going, follow me, even if that doesn't lead to the best outcome. How many of you know somebody like that? How many have a boss something like that? Oh, there were some very sheepish hands in the air. How many of you have a boss in your room, in this room right now? So although the ideal of Agile is adaptive planning, is shifting to find that maximum value, that takes a certain amount of trust from the organization. In order to be able to do that, you really need to build that trust. And what's the best way to build trust that I've found? Well, it's to be reliable. It's to make commitments and meet them. In other words, predict what you're going to do and then deliver on it. I think I have time for a very brief story. There's about 6 minutes left, right? Yeah. Several years ago at the Agile Open Northwest conference, I had the pleasure of talking to somebody who worked for Visa. Visa is not the kind of company I would expect to be very innovative in its software processes. And this person was talking about how he had a team that wanted to do adaptive planning, which is really a 3-star it's in the 3-star zone. It tends to come later because you got to build this trust. He had a team that was, as I understood it, very solidly in the 2-star zone. He wanted to move to the 3-star zone. And at Visa, performance was judged based on your ability to create yearly budgets and meet those budgets. You had to make a yearly prediction. You had to deliver on that prediction. Being 3-star, shifting direction is not something you can do with a yearly plan fixed in advance. It's just not practical. So what did they do? Well, if they could have done what Martin Fowler recommends and changed their organization by going somewhere else. But instead, they worked within that. They shipped reliably because they were a 2-star team and they had the ability to actually work within that 1-year budget, make a prediction, and deliver on it. And they said to their boss, we would like to try this adaptive planning. We think we can get more value for Visa by doing this. And the boss said, yeah, I trust you. Let me talk to my boss. And he talked to his boss, and that person talked to their boss, and that person talked to their boss. 5 years later, 5 years later, the question comes up to the CEO of Visa, because that was the only person who had the authority to make that kind of change. And he listened to the argument of his senior VPs, who had listened to the arguments of their VPs, who had listened to the arguments of junior VPs, who had listened to the argument of the directors, and said, okay, approved. And now that team at Visa does not make a yearly budget and roadmap. Instead, they change their plans. They adapt. They have permission to work in that way. They're judged based on net profit per employee, customer satisfaction, and other business-centric metrics. In other words, classic 3-star Agile, which is sort of what, when people say what Agile is all about, what they mean, but what very, very few of us actually do. So, when should we predict? If we can predict, should we? Well, we should predict when we need to build trust, or when there's significant business value. It is true that there are cases where there's a real business need to coordinate with others and that we'll get real value out of doing that. And I find that people often overstate that importance because they're afraid of that unknown future. They want that bright, shining line. The real business value from predictions is much less common than people think. People want a prediction, but if you really ask, how will we profit from this? It's hard to get an answer. Or how will we get other value? Profit's not the only source of value. I have time for one question before we wrap up. Any questions? So this is a subjective decision, but the Agile Fluency Project has a diagnostic that teams can use to self-diagnose. There are certain skills that you'll see from that teams at different points along the journey will exhibit, and the self-diagnostic is a way for teams to evaluate those. It's not something anybody external can do very easily, so it's a team self-assessment. We've put a lot of work into it. I think it's pretty good. If you do a Google search for Agile Fluency Project, you'll find a Google group where we discuss it and where you can get access to it. All right, if there's more questions, I can take them afterwards. So to wrap up, let's bring this all together. Teams that are early in their Agile journey, that are basically at the 1-star point, the ones that don't have the Agile engineering practices, they can't make useful predictions except at a very small scale. Teams who are using adaptive planning, typically the 3-star teams, shouldn't make predictions because that decreases their ability to optimize value, except in those cases where there's more value at stake. And that's a judgment call that 3-star teams are capable of making. They can say, well, the cost of predicting means less adaptability, but we see this benefit, so we're going to take that hit. But 2-star teams who are working to get into that 3-star bust zone, those teams should make predictions in order to build trust and create permission and to do adaptive planning and start moving into that 3-star zone. So 1-star can't, 2-star should, and 3-star doesn't need to. So, estimates or no estimates? Well, this is a programming conference. It's a Boolean expression, so you know the answer. Estimates or no estimates? Yes. Thank you.